Hey, we have here today another integral from the Scranton integration bee 2017. This was problem number 22. We have the integral of secant squared x tan squared of x dx. Yeah, this doesn't look too bad because we know that the integral actually of just secant x tan x would be secant x. And so having those squared x's there is going to just make it a little more complicated. But what I'm going to do is try to handle that. I'm going to make a u substitution for that. So we'll call our u equal to square root of x, and I'll just solve for x, which would be u squared, and then we'll take our derivative. So for dx, derivative of u squared is just going to be 2u du. And now we'll substitute this. So we'll have just secant of u, and then we're going to have tan of u. And again, our dx is going to be 2u du. I think what I'm going to do is just take this 2 and let's bring it out front of the integral. So let me clean that up a little bit. So let's draw in a 2 right here, and let's make it pretty this way. And now at this point with this integral here, I think this is in good shape for integration by parts. Like I mentioned earlier, we know how to integrate this thing with no problem, and u is going to be nice to differentiate. So what I'm going to do is set up my table for integration by parts, tabular integration with the DI method. I'm going to differentiate my u, and we'll just integrate secant u tan u. And like I mentioned before, integral of secant u tan u is going to be just the same thing as secant of u. And then for our derivative of u, we're going to have just 1. And then let's differentiate one more time. Derivative of 1 is going to be 0. Derivative of secant u is going to be natural log absolute value secant u plus tan u. Good, and we'll crowd it down there. And so then our solution is going to be just on these diagonals. The last row, we've got this 0, so we don't have to integrate again. So we just need the diagonals, and that's going to be our solution in u. So let me write that out. We're going to have the first one here, we're going to have u secant of u, and then we're going to have minus natural log of absolute value secant of u plus tan u. And now all I need to do is just back substitute to finish it off and all these u values, just recalling that our u value is just square root of x. So let's do this thing. So if our u is square root of x, we're going to have square root of x here, secant of square root of x minus natural log absolute value secant, draw it carefully, plus tan square root of x absolute value plus c. That's going to be it. So not too bad, just a u substitution integration by parts, and we're done pretty quick. So I'll stop it there. Thanks everyone for watching today. Have a great day.